Hello everyone, myself Dr. Pradeep Kumari MR, working as Assistant Professor in the Department of Pharmaceutical Chemistry at KLE College of Pharmacy, Hubli. In this session, I will be discussing on the topic antioxidants. First, let us see the definition. Agents which inhibit oxidation and are commonly used to prevent rancidity of oils and fats or deterioration of other materials through oxidative process are known as antioxidants. These compounds can act and function chemically as reducing agents. Now let us see the mechanism of action of antioxidants. Since chemically they are reducing agents, they prevent oxidation of other species by either of the following methods. In that, the first one is by getting oxidized themselves in place of active component as they undergo oxidation more readily than the active component, or by reducing the already oxidized active component back to the normal oxidation state. Action is based upon oxidation reduction, that is redox reaction, in which the antioxidant itself gets oxidized. In redox reaction, there is transfer of electrons from one compound to the other. Therefore, the loss or gain of electrons is used to balance the oxidation states on both sides of the half reaction. Now let us see the same mechanism of action in the form of reaction, taking the general example in the reaction. OXA is the oxidized form of compound A. Red A is the reduced form of compound B. Then the half reaction can be written as OXA plus electron reversible reaction red A. Next, red B reversible reaction OXB plus electron. The overall redox reaction can be given by the following equation: OXA plus red B reversible reaction red A plus OXB. Half reactions OX1 plus electron reversible sign red 1, red 2 reversible sign OX2 plus electron. Total redox reaction: OX1, that is easily oxidized substance, plus red 2, that is acting as antioxidant reversible sign red 1 plus OX2. Here I have given a figure where we can understand how does this oxidation and reduction reactions actually take place through a simple diagram. So in the first, let us see the oxidation reaction taking into consideration of compound A. Here, compound A loses electrons and gets oxidized. Now let us see the another reaction, that is reduction with respect to the compound B. Compound B gains electrons and gets reduced. Next, let us see the NERNST equation and its importance. The efficacy of a chemical substances to undergo oxidation reduction can be determined by electrode system. The electrical potential developed by cell can be measured by the equation. Voltmeter and the measurement of electric potential is made by the NERNST equation, which is as below. In this particular equation, the different variables are first the E, which is the potential of cell in volts. E naught is the standard potential, that is 0.0591 is the numerical combination of gas constant, absolute temperature, Faraday constant. N being the number of electrons involved and concentration of red divided by concentration of ox is the ratio of concentration of oxidant and reductant respectively, where In refers to the logarithm. Next, selection of inorganic antioxidants. In this study, we will be concentrating only upon those antioxidants which are inorganic in nature. So let us see some of the important properties which the antioxidants of inorganic in nature should possess. First, it should be non-toxic. Second, it should be physiologically and chemically compatible. Third, it should be chemically inert. Fourth, it should not create any solubility problem. The most important criteria for selection is the activity. It should have a desired redox reaction which can be measured from standard electrode potential and by NERNST equation. Now let us see the different inorganic antioxidants. In that, the first one is sodium metabisulphite. It has got a molecular formula Na2S2O5 and molecular weight 190.1. It should contain an amount of sodium metabisulphite, that is Na2S2O5, equivalent to not less than 66% and not more than 67.4% of sulfur dioxide. Coming to the preparation, it is prepared by passing sulfur dioxide gas through a hot solution of sodium hydroxide. In the process, sodium bisulfite is formed, which decomposes to give sodium metabisulphite. Reaction for the same is given here. Now let us see the properties of sodium metabisulphite. It is a whitish yellow deliquescent powder having the odor of sulfur dioxide. It is soluble in water and forms sodium bisulfite. Uses: it is used as an antioxidant in solutions of drugs that contain the phenol or catechol nucleus. It is also used as a reducing agent in ascorbic acid injection. Now let us see the assay for sodium metabisulphite. It is based on the oxidation reduction reaction, as sodium metabisulphite is a strong reducing agent. It gets oxidized to sulfate by iodine solution. A weighed amount of sample is dissolved in water. To this, known excess of 0.1 N iodine solution and 1 ml hydrochloric acid is added. The excess of iodine is back titrated with 0.1 N sodium thiosulphate using starch mucilage as indicator towards the end point of titration. Here are the reactions for the same assay. Coming to the next compound, that is hypophosphorous acid. It has got a molecular formula H3PO2 and a molecular weight 66. It contains not less than 30% and not more than 32% hypophosphorous acid. Preparation: it is prepared by decomposing boiling aqueous solution of calcium hypophosphite with oxalic acid. This is the reaction for the same. Properties: it is a colorless or slightly yellowish tint, odorless liquid. Uses: it is used as an antioxidant. It is also used as a reducing agent. Coming to the assay, being a monobasic acid, it is directly titrated with standard sodium hydroxide solution using methyl orange or methyl red as indicator. The next compound, sulfur dioxide. It has got a molecular formula SO2 and it has got a molecular weight 64.06. Preparation of sulfur dioxide. It is prepared by burning sulfur in presence of the oxygen. Here is the reaction for the same. Sulfur dioxide can also be prepared by other methods also. By roasting of metallic sulfates, the sulfur dioxide can be obtained like cuprous sulfide plus oxygen undergoes a reaction to give copper oxide plus sulfur dioxide. Similarly, zinc sulfide undergoes reaction with the oxygen to give copper oxide plus sulfur dioxide. Properties. It is a colorless, non-inflammable gas with characteristic pungent odor. It is soluble in water and alcohol. The gas can be liquefied which boils at minus 10 degrees centigrade. Uses. It is used as antioxidant in pharmaceutical preparations like injections. It is used in the manufacture of sulfuric acid. It is used in wool, wood pulp and in sugar industry for arresting fermentation and removing color. Assay. It is based upon absorption of sulfur dioxide into 0.1 N sodium hydroxide to form sodium bisulfite. The bisulfite so formed is then titrated against 0.1 N iodine solution using starch as indicator. The next compound is sodium nitrite. It has got a molecular formula NaNO2 and a molecular weight 69. It should contain not less than 97% and not more than 101% of sodium nitrite. Preparation. The commercial method of manufacturing sodium nitrite involves absorbing nitrogen oxide gas and oxygen into sodium carbonate's solution. The solution is finely concentrated to crystallize out the product, that is sodium nitrite. Here is the reaction for the same. Now let us see the properties. It occurs in the form of white granular powder or white crystals, has a saline taste, it is freely soluble in water and sparingly soluble in alcohol. Uses. It is used as preservative. Assay. It is based upon oxidation reduction reaction in which nitrite is oxidized to nitrate by potassium permanganate solution. Here is the reaction. Next, sodium thiosulphate. It has got a molecular formula Na2S2O3 5H2O and a molecular weight 248.2. It should contain not less than 99% and not more than 101% of sodium thiosulphate. Preparation. It is prepared by the reaction between soda ash, sulphur dioxide and sulphur. Here are the reactions which are involved in the preparation of sodium thiosulphate from soda ash, sulphur dioxide and sulphur. Coming to the properties, it occurs as transparent, odorless, monoclinic prisms or as a crystalline powder. It has a cooling, bitter taste. It effloresces in dry air and deliquesces in moist air. It is soluble in water and insoluble in alcohol. Uses. It is useful in treating parasitic skin diseases. It is effective in cyanide poisoning as an antidote. Coming to the assay, it is assayed directly by titrating an accurately weighed, that is 1 gram sample in 25 ml water against 0.1 N iodine solution using starch as indicator. So after studying this antioxidant chapter, we need to know some frequently asked questions on this topic. So some frequently asked questions include: what are antioxidants? Discuss the mechanism of action of inorganic antioxidants. The second question is: what are the criteria for selection of inorganic antioxidants? Third, write a note on NERNST equation and its importance in antioxidants study. Fourth, give the method of preparation, properties, uses and assay method for hypophosphorous acid. Fifth one, give the method of preparation, properties, assay and uses of sulphur dioxide. And another question is: list the compounds of sodium which acts as antioxidants. Give a method of preparation, uses, properties and assay for any two compounds of sodium used as antioxidants. Thank you.